Remember The Matrix? That whole rug pull moment? Questioning everything you thought was real.
Oh, absolutely. Such a powerful concept. And it really sets the stage for what we're diving into today, actually.
Right, because we're looking at a real claim from a scientist, no less, suggesting something maybe just as mind-bending.
Exactly.
Yeah.
A UK scientist is proposing that gravity itself, well, it might actually be a clue that our universe is, simulated.
Okay, wow. So we've got this article covering the theory from Dr. Melvin Vopson, and our mission here is to really get under the hood of his argument, understand why he's making this connection.
Yeah, let's unpack it. Dr. Vopson, he's a physicist, and he's been doing some really interesting work where information theory meets physics.
Information theory and physics.
Okay. And his big idea here, the core of it, is this link he sees between gravity, how the universe works, and how computers handle data, specifically data optimization.
Gravity and data optimization. Okay, I'm intrigued. How on earth does he connect those two? Seems like completely different worlds.
Well, think about data compression, right? How computers shrink files, make things more efficient. Vopson's proposing that the universe might be doing something fundamentally similar. He suggests it's constantly trying to be efficient with its information. And gravity, the force pulling things together, he thinks that could actually be this process in action. Cosmic data compression, essentially.
Whoa. Okay, that's a different way to look at gravity.
Right.
The article quotes him, I think it was from the Daily Mail.
Yeah, I saw that one.
He says, the universe evolves in a way that the information content in it is compressed, optimized, and organized just as computers and computer code do, and then the kicker. Hence, gravity appears to be another process of data compression in a possibly simulated universe.
Exactly. So it's not just like compression for him. He's suggesting it fundamentally is a form of data management.
Okay, so to get this straight, gravity pulling, say, a star together, that's the universe tidying up its files.
That's the analogy, yeah.
Yeah.
And it ties into this concept called information entropy.
Right, information entropy. Explain that a bit.
So information entropy, in this context, is basically about how much information is packed into an object or region of space. Think of it like complexity, or the number of possible states something can be in. More entropy, more complexity, more information.
Got it.
And Vopson's study suggests gravity reduces this information entropy. It simplifies things.
Okay, so how does that play out? Like, give us some real-world examples of gravity reducing this complexity.
Well, think about galaxies forming. You start with just clouds of gas and dust spread out everywhere, right? A lot of randomness, high entropy maybe.
Yeah, just chaos.
Then gravity pulls it all together. It forms stars, spiral arms, this highly structured galaxy. Vopson would say that structure is informationally simpler, more compressed to the initial chaos.
Okay, I see. Instead of tracking billions of random particles, you track one galaxy, a few star clusters.
Exactly. Or planets orbiting a star. That's a more ordered, predictable, informationally cheaper state than if those planets were just drifting randomly through space. Gravity creates that order.
Huh. There's another quote in the article that clicks now. To put it simply, it is easier to compute all the properties and characteristics of a single object in space rather than multiple objects. That is why objects in space are pulled together. It's a computational laziness built into physics.
Kind of. Or computational efficiency, maybe.
Yeah.
And this isn't totally out of the blue for Vopson. He's been working on information theory and entropy for a while.
Oh, really? So there's a backstory here.
Yeah, he previously looked at entropy in information systems generally. And then specifically, I think it was back in 2023, he was applying similar ideas to biological systems, how they manage information, stay organized, despite the tendency towards disorder.
So he saw this principle of information optimization in biology.
Right, this drive towards efficiency and organization.
And now he's thinking, maybe this applies to the whole universe, to gravity itself. That's quite a leap, connecting life science to cosmology like that.
It is a big leap. But the thread connecting them is this idea of information. He also talks about the sheer scale of computation needed if our universe were a simulation.
Right. Unimaginable complexity.
Exactly. So he argues any feasible simulation of this scale would almost have to have built-in data compression and optimization. It wouldn't work otherwise.
And gravity, he thinks, is maybe exhibit A for that optimization.
That's what he's proposing. He sees hints of this optimization principle everywhere, not just gravity, but also in like digital data patterns, biological coding, even mathematical symmetries. It's all about efficiency.
It's like finding the programmer's efficiency tricks coded into the laws of physics.
Pretty much. And he summed up his latest findings quite well, I thought. He said something like, "My findings fit with the thought that the universe might work like a giant computer or our reality is a simulated construct.
Yeah, I remember that part.
He goes on, just like computers try to save space and run more efficiently, the universe might be doing the same. It's a new way to think about gravity not just as a pull, but as something that happens when the universe is trying to stay organized.
So it reframes gravity entirely, not just mass attracting mass, but an underlying informational process keeping things tidy.
Precisely. It moves beyond Newton and Einstein, in a way, suggesting this deeper informational layer beneath the physics we observe. Of course, it raises huge questions, too.
Like how? How does information compression actually exert a force? What's the mechanism?
Exactly. What does that look like at the particle level? That's the big unknown. And crucially, are there ways to test this?
Yeah, can you make predictions? Can you design an experiment that would show gravity behaving differently based on, I don't know, the information content of the objects involved?
That's the challenge, isn't it? Vopson's work really just opens the door. Maybe future research could look for subtle gravitational effects linked to information complexity in ways we haven't thought to measure before. It's super speculative right now.
Highly speculative, yeah, but fascinating.
That's often how science moves forward, though, with these big, perhaps strange-sounding ideas.
So wrapping this part up then, the key takeaway is Dr. Vopson's theory. Gravity as cosmic data compression. A potential sign, he argues, that we might be living in a simulated reality.
That's the core of it. A really provocative idea linking fundamental physics to computation and information.
It definitely leaves you thinking, and it prompts a question, maybe for you listening.
Yeah, definitely.
Yeah.
If gravity, this force we thought we understood pretty well, could actually be about information processing,
Yeah.
well, what else could be?
Right. Could electromagnetism or the nuclear forces, could they also have some hidden informational role?
What if we started looking at all of reality, and not just through matter and energy, but through information and computation? How might that change our whole understanding of, well, everything?
It's a perspective shift that could potentially rewrite the rules. Definitely something to mull over.